In this episode, we look at some ideas on how to approach and write Chapter 3 of your thesis. Chapter 3 is where you give the reader a clear design of the layout of your study, how you plan to do your empirical work, as well as how you plan to analyze your data. Students need guidance from their supervisors when they choose a suitable design. They often make a mistake in thinking that Chapter 3 does not need as much reading into the literature as Chapter 2. Be aware of this, because if you have not read enough suitable designs to choose from, it will be akin to planting your study in potentially barren soil where it will not yield the fruits that you are looking for.
Nee, maar dis nie regte plek. Laat ek jou wys was die regte plek om te plant. Op die klippe, jy sal op die klippe plant man. Dis 'n tuin.
Hona le plek e nngwe ka go isimfa.
Laat ek jou wys waar moet jy plant. Reg plant. Hier so jy is nie vir plek om te plant man. Megtig. Vat daai ding kom agterna my toe. As dit reg so.
So do you want me to come with you?
Ja, laat ons gaan. Want hier so is net tuin. Laat ek jou gaan jou wys was die lekker tuin om te plant.
Okay.
Ja, pak jou goed op.
So where are we going?
Ons gaan aan die ander kant by die
Ander
plas,
kant.
wat ek jou gaan wys. Vat alles vir jou na toe, dan kom agterna my.
Okay, let's go. Is that better?
Ja, is yami. Is yami. Right there.
Dis reg. Perfect. Mooi.
In the following discussion between Prof. Henning and Francois, you will hear key questions that should be asked, which will guide you in the choice of your design. Remember that a clear research question is the first crucial step in the process.
So, Francois, what is your research question? I didn't quite get it.
Professor, I'm interested in finding out what it is that young children know about science.
Oh, my word. Difficult one. How does one go about finding out what young children know?
I'm very unsure about that. I was thinking of asking them questions, and specifically in a group.
That's why you did that pilot.
Yes, for the study I decided to do a little science demonstration with grade R children and with grade 3 children, because I wanted to find out what is it that they know about astronomy, what is it that they know about biology.
Oh, that's a difficult one. And what happened?
Very interesting responses from the children.
Yeah.
But I must say, one of the biggest challenges for me whilst doing the pilot, the children that I investigated, they were isiZulu speaking, and I don't really understand the language. So especially with the grade R children, they don't know English that well. So they spoke in isiZulu mostly. And here and there, a few English words. But with the grade 3s, they were more versed in English. But they also threw in a few of the isiZulu words.
Yeah, sorry for interrupting you. Imagine that you did understand isiZulu. What would you have done? How would you get that data to come alive in the analysis?
Well, that's one of the biggest challenges for me, because I'm not entirely sure what is it that I should be looking for. So asking them questions and showing them some of the science demonstrations, I was wondering what is it that they are thinking. How would they express that, what they are thinking, and explain to me the phenomena that I showed them?
Okay, so you did the pilot. It was in isiZulu. I'm sure you got translations of whatever you needed.
Yes.
And so where are you going now? Is that your issue?
Yes, I'm so caught between, should I be analyzing it qualitatively or quantitatively?
Yeah, that's an age-old question. And there's no easy answer. If you have data that is in language, how would you quantify that? So, to talk about qualitative or quantitative, and that it is a specific type of tradition, yes, but it depends on your data. So imagine you have that data now. How would one analyze that? How would you design a study that could really get into the depth of what the children said? Because that's all we know, what they said in your pilot. Is there something else you had in mind that you could do? Because this is a really crucial problem. We don't have many studies of children's development of science concepts. So you need to find this out. What else can you do?
What was particularly interesting for me was I investigated them in their classroom situation. So we had about 25 children responding simultaneously.
Wait.
So it's extremely difficult to find out what it is that the individual knows. So I got a helicopter view of what the classroom or what the children in the class, what they thought. But it was extremely difficult to find out what the individual was thinking.
So why are you so interested in an individual?
Because at the end of the day, the individual is important. It's
Okay.
the individual that needs to know the science concepts and develop science literacy so that they, as an individual, could prosper.
Okay, so you are getting closer to finding a way to find out. So what are you thinking? What other possible methods are there for you to find out what the children think and know and how they express it? Have you thought of any other method?
We could possibly do surveys with the children.
Really?
Well, they are very young.
Yeah.
It would be difficult, and especially if we would ask them survey questions in English, it might be difficult for them to understand the language per se.
But now, were you to do it in isiZulu, didn't you mention earlier today that you had another method in mind?
Yes, I was extremely interested in letting them perform tasks,
Ah,
because then you eliminate the language issue. If they could work with something or if they could demonstrate something, maybe I would get a glimpse into their science concepts.
have you read anything about this? Do you know of people who've done this? Because you need to use methods that have been proven to be reliable.
There are some scholars, especially if we go back to the 1930s, somebody like Jean Piaget, who used clinical interviews and clinical tasks with children to try and figure out what is it that children are thinking.
Okay, so that's a reliable, proven method to use clinical interviews, and you say task clinical interviews. What would you think? How do you plan that?
Well, if I would go back to the literature, some of the scholars like Stella Vosnaidu, who worked specifically on astronomy, asked children to draw pictures
Yeah.
and to work with clay.
Ah,
And I was thinking maybe that's something that I could replicate in
Yes.
my study.
okay. So you have said that you want to do task type of interviews
task-based.
with clay and or drawings, and then you would analyze that. But how would you do that, and how would you record it?
Well, I think I'd want to do it in two ways. Get both visual recordings, but also audio recordings. So the best way would be to film the interaction between an interviewer and the individual child.
Okay, and so you're planning to do these task-based interviews. You're filming them, then you have these films, and you have a record of what they said. So how would you analyze that?
I think there are a few options. One would be video analysis.
Yeah.
Another one would possibly be discourse analysis. But I think the language might be a problem there again, especially when the children don't really express their concepts articulately in a specific language, especially because they're young.
Okay.
So maybe I should consider inductive coding.
Okay. So that's a specific way of analyzing. So you would, and you have somebody that you can rely on, some literature, some author, to do that. But now something else is worrying me. You know, students always want to know, what about the theoretical framework? Where do you build your knowledge? Where does it come from? So if you study these children and you've got the data from the videos and you heard what they say, and if it's in the isiZulu, you will have obviously a translation and a back translation in a reliable way, so we assume that. But where would your analysis come from? What would you be looking for? So what would you plan for the clay work?
My
Give me a
understanding.
topic. Sorry for being rude. Give me a topic.
So a topic to investigate.
Yeah.
So let's work with maybe vitalistic biology, whether an object is alive or not.
Okay.
So what I'd like to do is determine whether the child knows what the characteristics of living organisms are.
But not like in a class where the teacher says, what are the characteristics of living organisms? Because that's rote learning as far as I'm concerned. So what would you do to find out for real?
Well, I would present them with objects and then ask them whether they think that this object is alive or not, and then to explain why it is that they have that specific answer.
Okay. So, and then you would analyze their responses.
Yes.
And you would do that qualitatively. You'd use either inductive content analysis or discourse analysis. Okay, that sounds great. So, you know, sometimes people want to know, so what type of study is this? What genre? What name would you give this study?
In my opinion, I would think that it's a case study,
Okay.
because it's a very isolated incident that I'm studying. I think for a PhD, I think the dream would be to investigate as many children as possible.
Sure.
But I think for the specific scope of the study, it's important to look at a small-ish sample.
Okay. And so if your unit of sampling are young children in a school, which children would you study? Your unit of sampling?
I think what I'd like to do, because I'd like to see what the progression is within the foundation phase. There's not a lot of science in the foundation phase curriculum.
Sadly.
So if I could determine what it is that grade R children know and what it is that grade 3 children know, we can compare the two and then see what the progression is from grade R to grade 3.
But here's a problem, eh? Because where would these children be? Because if the one group of children is in a school in one place, and the other, are they going to be in the same school? Are they going to have more or less the same type of education by more or less the same teachers? Otherwise, what progression are you talking about? Will
So-
they be in the same school?
Yeah, I think it would be important that they be in the same school. And I think it would be difficult to within the time frame of the study, try and do too many individuals or include too many individuals in the study.
So your sample would be small.
Yeah.
Would it be with a lot of variance with the children who are in the same school, growing up with the same language, having more or less the same education from grade R to grade 3? Would you find out more about the children because they would be different?
If I understand the literature correctly, what we do know about children's conceptual development is that it is socio-constructed or socially constructed. In other words, what their history is, where they come from, will have an influence on what it is that they know.
Some influence.
Yes.
It's not,
And their exposure to especially science phenomena.
So what is, you said you were studying something else, not just the biology, vitalistic biology.
Observable astronomy.
Tell me what that means, because that's crucial for your study. So what do children observe?
I think one of the most interesting questions for adults and for children is the Earth really round? Because what we observe is that the Earth is relatively flat. But what we know from science and years of exploration is that the Earth is a sphere.
So how would you find out what the children think and know?
What I've considered is to have them express it by using the clay models. So giving them a piece of clay or giving them the option to choose different colors of clay and then asking them to show me what the Earth looks like.
And then later on, I assume you would video record this and
Yes.
then you would analyze the videos.
I'm worried about the design of my study. I have read a lot, and there are so many scholars trying to find out what I'm trying to find out. But I'm not sure what exactly to use for my study. So I just went out and I did a little pilot with a few children, and I'm not sure whether I'm getting the data that I need for my study.
Okay. Sometimes one just uses a method because you know it. And sometimes you choose a method because you don't know anything else. Sometimes you really don't have a clue what to do. And you just jump into the study like I think you did with that pilot.
Yes.
But that's what we do with pilots. We see what doesn't work. So it's okay to have a pilot that is a complete flop. That's all right. Many students, through all the years that I've supervised students, come with exactly that problem. They know one method, they want to apply it, and they don't really think this thing through properly. You want to find out something, you must search for the best possible method. And how does one do that? Now, it seems to me as if you've read a lot, maybe too much, so that you get a little bit more confused. Did you say at some point that you were worried or perturbed?
Yes.
Okay.
It's almost an overload of information, and I'm struggling to select exactly what would be the best for my study.
Now, that's when you go to a supervisor and to a team of the committee that assists you, the people in the committee who assist you. You won't find this on your own, because otherwise you could do a PhD without a supervisor. So one has to find this stuff. But once you have found it, once you found what doesn't work, and you've read a lot about what does work, you still have to do a small pilot and then say to yourself, hey, this seems to be working. Let me try this. But now you have to write up your design. That's so scary for most students. What do you put down on paper or on the computer when you have to write your design? And you do it step by step. First, what's this problem that I investigated? What's my main research question? And then, what's my unit of analysis? What's this thing that I'm investigating? As you said, kids' conceptions of certain phenomena in the natural world. That's a unit of analysis. What's my unit of sampling? Who are the kids that are really going to help me to understand this? And then, sure, which data collection methods do I use? Now, in your story about your pilot, you said you did this demonstration and you watched the kids and they all spoke together. Pretty much a wrong decision, you now realize.
Yes.
Yeah, but that's okay. So there are other methods, and you've told me also a little bit about these other methods. So you have to put down your data collection methods, your unit of sampling, the population from which you are drawing this unit of sampling. And then very, very importantly, how am I planning to analyze this data? And that's where most of the students struggle most. You have this data, what do you do now? Now, if you use statistical analysis, wonderful. You put it into the computer and it analyzes stuff for you, but you still have to interpret it. You still have to think, you still have to know something. So if you've analyzed it and you have some findings, then you have to think, so how does this fit in my whole story of my design? Well, there are 5 important steps for you to follow.
But where do you start?
So, well, you have started, you just don't know it. You have read widely, you have a research topic, you have a research question, you have a specific aim, which is to find out. Maybe you also have a purpose. Why do you want to do this? I mean, you can't make scientists of young kids, so why are you wanting to do this? That's important.
Professor, how would you define the design of a study?
A design is a plan. Straightforward, as simple as possible, and streamlined. Planning what you're going to do. It's a strategy. First I'm going to do this, and this is how I'm going to do it. Then I'm doing that, and this is how I'm going to do it. And this is why I'm doing it. And there are other people who have done it like this, and it worked. So a design isn't a dream. It's a real technical thing.
Is it enough to describe my plan for the study?
Clearly not, because if you just say, I'm going to do this, that, and the other, we still don't know if these are good ways to go about the design. We need literature. We need people who have argued that the steps you take are good steps. So you're making an argument, you're making a point. It's as if you are in court and you have to convince the judges that you have the right evidence for this. So your right evidence comes from the literature, from the methodologists who have done this before, specifically the methodologists who've worked in your field, in science concept development, as you spoke about. So you can't just pick a design and say, I'm going to do this and it's going to be really nice. No. You have to say why it is a good design, why you choose it intellectually. not just because you like to do this.
I did this pilot study now and I got data, but I'm not happy with it and I'm not sure if I can use the data for my study.
Did you learn something
Yes,
in that pilot?
yes.
That's what a pilot is for. So the pilot wasn't successful. So what did you learn?
Well, most likely what not to do.
Exactly. So you did something that didn't work. But it's not wasted because now you know. So a pilot is always part of a design. You know, it actually makes me think of the tomatoes I put in the wrong spot. Look at this. Do they seem happy?
No.
So when it's growing time again and I do the tomatoes in the garden, I won't put it here. And that's exactly why it's important. So now I will take photographs of this to remind myself what a big flop that was. You have to have, when you do a design, information from people who know better. I didn't speak to my neighbor, who is a fantastic gardener. I didn't ask her, Claire, is this the right place to put these tomatoes? I just put them here because I wanted them to be close to the house so that I could just have them close by. It didn't work. And so you need evidence from other people. You need evidence from the scholars who've done this before. Specifically, people who've studied it in the context like yours, but also people anywhere in the world, because kids are not that different. They share some ideas and some developmental things. So a pilot is never a waste. And so when you plan your study, when you write out your design, you say you do a pilot, you describe it.
So the different components of my study should fit.
They should fit. You have to have coherence from the beginning to the end when you are ready to write it up. And you have to make quite sure that the way you investigate this research question that you've posed, that fits with everything else. And it's different small components. How you do interviews, how you do these tasks that you talked about, how they fit together as well. Otherwise, you're all over the place. We want you to be focused in one good place with different components where things fit, like really fit.
How will I know if my study is reliable?
I don't think you will ever know completely. But what you will know, and what others will judge, is what did you do, when did you do it, how did you do it, so that if somebody were to replicate your study, they have a guide. If they have no guide, then we can't trust you because we don't know exactly what you did. And to be doing a study that is reliable means that you must have a very clear trail of what you've done. That's a beginning. There are many other ways to find out, but this is at least a beginning. You have to have a good record of exactly what you did.
The participants of my study are young children. How do I ensure that I do not exploit them?
Well, first of all, you have to have permission from the parents or guardians. You need to make the children feel that they're in a safe space. So it's crucial that you go through the ethics committee of your university, because they have to stand in for you. So yes, it is something to be concerned about, because you have to protect the children and respect them.
Here are some important facts to keep in mind when you plan the design of your study.
As a master's or doctoral student, you are learning to become part of a research community. Ask yourself the following questions. How do I know what I know? My epistemology. What do I believe about the nature of reality? My ontology. And how do I study the world? My methodology. We ask questions about ontology. What is reality? However, in educational research, there is no real single reality. Histories and circumstances make different realities. Studying different realities requires different techniques, different methodologies, and with different views of knowledge. So, when you design a study, you have a methodological position, an ontological position, and an epistemological position. This means you believe that knowledge can be made in a specific way, in a specific place, for a specific reason, and for this, one asks a specific research question. When thinking about your research design, a good place to start is with this specific research question. From the question will come the design of the study. This means that you will be planning how to go forward with a specific strategy of collecting and analyzing data with a particular sample. If these components are coherent, there is design logic. For example, Francois is interested in children's early science concept development. He also talked a lot about the process of his research. In other words, his methodology. The methods and techniques he would use to collect and analyze data. But remember, it cannot simply be a description of what you intended doing. You have to argue based on what you have learned from other researchers. Ask yourself why you have decided to use a particular method to collect data. Why you are investigating this particular sample of the population, and why you will analyze your data in a particular way. Ideally, you will refer to leading methodologists in your field of study. And by the way, it is also possible that even with a good plan, something may go wrong. This is why it is a good idea to test part of your plan to see what happens. For this, you need a pilot study. In Francois' pilot study, he tried out a particular method of data collection and discovered that it did not give him the information he needed. For instance, pilot studies are useful when doing interviews to test the interview protocol. Are the questions suitable? Do they lead to worthwhile responses? Likewise, other methods could also be tested in this way. In Francois' pilot study, he tried out a particular method of data collection and discovered that it did not give him the information he needed. Even though Francois' pilot was not successful, it was still a part of his process of research, and he will write about it and what he has learned from it in his thesis. How do you account for the various steps you have taken in conducting your research? You do so by describing in great detail what you have done and providing the reasons why you have done so. This is the audit trail of your study, making it possible to replicate or to repeat your design. It could also contribute to the reliability of your study. Another important aspect of the design is to plan for any activity with ethical implications. Francois had to include a big section on how he would ensure that the child participants would be respected and not be harmed or exploited in any way. All researchers must get permission to conduct their research, usually from an ethics board which looks closely at the rights of participants. Then, you also have to get permission from the participants themselves. It is usual to ask them to provide written consent that they will participate in your study. In the case of children under the age of 18, Francois will have to get legal consent from a parent or guardian. But he will also have to explain the research to the children and ask them if they are comfortable participating in his study. In other words, he obtains their assent. There are various interesting and age-appropriate ways of getting young children's assent which you could consider.